Hello, and welcome to today's lesson in quantitative reasoning. We're going to talk about compound interest. We've covered simple interest, and the idea of compound interest is based upon an understanding of simple interest. Some of these slides were made by your textbook publisher, so I'll put those, and I've added the ones that look a little blanker, a little less fancy, are ones I've added to this. But in this lesson, we're going to look at annually compounded interest. So when you compound interest, basically you get interest on the interest. How often you add the interest into the account and it starts gaining interest can be annually, quarterly, semi-annually. See that, so that's periodically compounded interest, something besides once a year. And then we're going to use the formula to find the new amount of money you have in an account. So what is compound interest anyway? Compound interest is a very, very powerful phenomenon. Understanding the power of compound interest will help you in your financial future, particularly when it comes to savings. The idea of compound interest is, you'll see in the formula, the longer time you have to invest something, the more money you can make from it. So that's why they tell you start saving for retirement early. Because if you save for retirement early, you need to put in less money now to have some certain amount later than you would if you waited until 10 years from now even. So even if you can only put in a small amount now, you should start saving for retirement early because of the way the math of the compound interest works. So it's a calculation of interest where you, instead of just simple interest, for 8 years, every year, or every half a year, every so many times, the interest you've already earned gets basically put back into the principal. So it calculates interest on the principal plus the interest. So let's talk about this. Find the interest earned on a $10,000 deposit, 8% annual interest compounded annually. So most of the time our interest rates are annually, and that just stated that. But so this is going to be compounded annually. So what's going to happen is you're going to find the interest on $10,000 at the end of year one. In that case, what we see is the principal is $10,000. And then the principal plus interest. So here's your interest. This is your simple interest. Principal rate times time, that's interest. And this is the principal plus the principal rate times time. So this is at the end of year one, how much money would be in the account if you only invested it for 1 year. This is where the compounding comes in. We're compounding annually. So when we start the second year, this is our new principal. So we have another $800 that's going to gain us interest. Now 8% is a pretty high interest rate to get on savings right now. There was a time in my life when it wasn't, but if you get like 2%, you're doing great. But also, the average rates of return in the stock market predictions, this is kind of what your finance guys will do. They won't necessarily figure an 8. Maybe it'll be more like a 5.5 or a 6 or even a really conservative 4.5. But they're considering it to be compounded annually because the money you make in the account stays in the account and continues to grow. So anyway, at the end of year one, we have $10,800. That becomes our principal in year two. So here we go. There's our principal plus our principal times rate times time. So the amount of interest I earn in year two is $864 compared to the $800 in year one. And now the total amount of the account is $11,664. That becomes the principal in year three. So I do that again for the third year. I see I made $933 in the third year, and the total amount is $12,597.12. So notice the interest goes up every year. I get more and more interest even, in addition to the principal going up. Now, for the fourth year, principal, this should say 4 years here. So here's the beginning of the fourth year of $12,597.12. Here's the interest on that. This is your R, this is your T, this is your P. And you get $13,604.89. Notice the interest in the fourth year was over $1,000. In the first year, it was only $800. So this really is making a big difference in how much you're earning. Now, 8% is a rather large interest rate to exaggerate this calculation, but If you had done simple interest, that's how much money you would have gotten at the end of 4 years. If you had just done 10,000 plus 10,000 times 0.08 times 4, you would have had $13,200. By compounding once a year, at the end of each year, putting that interest, reinvesting it really, putting it back into the principal, $13,604.89. That's a $404.89 more that you earned because it wasn't simple interest, it was compounded. So this is very powerful. If I had gone out over more time, or if the interest rate had been higher, if interest rates higher, everything would have gone up. Even, interest rates in time will always make it go up, even with simple interest. But that amount that goes up is literally compounded. It's made even greater when you use compound interest. Now, if I told you, calculate how much interest you'd have at the end of 20 years, you'd be pretty tired of doing this calculation. So people who understand math have figured out a formula that I could have just immediately gotten this number knowing I'd invested for 4 years and I had compounded annually. There's a formula for this that we'll see on the next page. Here it is. It looks kind of complicated, but don't panic. It's just order of operations. You have a calculator to do this. A of T is the balance in the account after T years. So this is the amount at the end. This is the amount you start with at the very beginning. So in our case of what we just calculated, the P would be 10,000. R is the interest rate. In our case, we just did would be 0.08. N is the number of compounding periods in 1 year. If you're compounding annually means once per year. So N is going to be 1 for our case, and we used 4 years. So R, that should be a small letter R, the way they've used it in the formula, is the interest rate in decimal form. And notice there's an N here and an N here. Now, when N is 1, that's not too big a deal, although the one up here is a big deal when we do evaluate this. But if I had done 10,000 times 1 plus 0.08 divided by 1, because it's once per year, times 1 times 4, you have to be careful to multiply this first. You can't just put in 10,000, it should be 10,000 parentheses 1 plus 0.08 divided by 1 parentheses, and then raise it to the 1 and multiply by 4. If you do that, it only raises it to the 1, and then multiplies it by 4. You got to have either parentheses around that or figure out that that's a 4 ahead of time before you put that in. That's the mistake people make with this. If you're getting wrong answers on these compound interest formulas, you're making an order of operations mistake. I'm going to tell you, put that in parentheses. If your calculator doesn't show it as a superscript, make sure it's in parentheses. Just make sure it's in parentheses anyway. Because if you don't do that, it'll do the exponent first. It'll only see the 1 if there's no parenthesis. And then it'll take this whole thing and multiply by 4. That's not what you want to do. You want the 4 to be part of the exponent. If I had done this, I would have gotten the same answer I had on the last slide, 13,600 something. So I would have gotten that all in one step. You don't have to memorize this formula. It will be given to you. You should have it written down and have it available for answering questions on your homework. But so you have to learn, how do I know what P is? How do I know what R is? That's the same as it's been. So those two aren't too bad. What is this N? And T in this case is always going to be years, which has been mostly what we did with simple interest in these lessons. So if you're given months, you're going to divide it by 12. But T is always in years. So if you have 18 months, you're going to go 18 divided by 12 for T. All right, so what about that N? This is how you get N. If it's keywords, annually tells you N is 1. You have to read the word and translate it into what it means. Quarterly, there are 4 quarters in 1 year, just like there are 4 quarters in $1 with coins. N is 4. If the compounding's monthly, N is 12, because it's 12 months in a year. If the compounding's daily, N is 365, because nominally there's 365 days in a year. We don't worry about leap years. So if you see the word daily, you can use 365 for N. Okay? Now, if you're told it's compounded daily for 2 years, you're going to do 365 times 2. You're going to figure that out before you make it an exponent. So the most important thing to remember about using this formula is that we put the money in the account once and we let it sit there earning interest. This is not taking into consideration the fact that you may be adding money to this account, or you may be borrowing more, if it's a loan, borrowing more money against this account. But this is, the money's in the account once and it sits and earns interest. In a retirement fund, typically you would have something taken out each paycheck. So each month the principal would be a little different, or each week, depending, or every 2 weeks, depending on how often you get paid, the principal would be added to in addition to the interest that it's being earned. So here's an example. Certificates of deposit used to be a big deal when I was in college because interest rates were high. Interest rates on CDs, what we called CDs, could be in the 7, 8, 9, 10% range. Even mortgage rates were like 14 back then. So it usually gives a CD usually gives a little higher interest rate. You can't always, but you take it out for a period of time. So 6 months, a year, 4 years, 2 years. But you're not supposed to touch the money, and you can, but you lose your interest basically. So you deposit $3,000 in a CD that pays 6% yearly interest, which is, unless it says something bizarre about daily or monthly, that percentage is always going to be per year. Compounded monthly. This compounded monthly tells me in the formula, I'm going to use n equals 12 in the formula. 20 years is T is 20. So you got R equals 6 over 100 from the 6%. That's 0.06. You deposited $3,000. That tells you P equals 3,000. That's how you read these problems. You're looking for the letters that go in the formula. So here's how that works out. Now, I'm going to tell you right now, this is going to be where your problem is. Do not round this. Now, this doesn't have too many decimals anyway. What you should do, the way I would do this to avoid any order of operations issues, and I know some of you have fancy calculators that'll do this correctly for you as long as you can see it's in the exponent. I would do 20 times 12. I would get 240. Then I would do 1 plus 0.06 over 12. I would get an answer, and then I would raise that to the 240. And then I would get that answer and multiply it times the 3,000. That is the order I would do this. I would find this, and I would do this get an answer, or put it in parentheses just like this. You could do this, and then raise it to the 240, but I would calculate that 240 first, just to avoid that order of operations mistake, and then multiply by 3,000. The formula's in front of you. You have to learn to be accurate with the calculator. Order of operations, if you did 3,000 times 1 plus 0.06 over 12, and then your calculator did something like this, times 12, what your calculator would do, because it only knows correct order of operations, is it looks for parentheses first. It would do that. That's okay. Then it would do exponents. So it would take what it found there and raise it to the 20th, because it hasn't done multiplication yet. That's next. What you want to do is either force it to do that multiplication before it makes that number an exponent. You have to do that. Some of your calculators will put it in this nice format where it stays in the exponent unless you move it out. You won't have those issues. But if you're just using a basic calculator, which is all you need, you've got to be aware of this order of operations. So when you do all that, you get $9,930.61. You should do that in your calculator and see that it works. We'll have done some of this in class too. So here is a different question. This says after 7 years, she has this much. This is the A. You say, oh no, how do I solve for the A? Set up the problem. A equals P times all of this. I don't even know if your homework has any of these, but if it asks you for how much did she initially place, they're looking for P. So what you do is you calculate what P is multiplied by. You get a number for that. And then you're going to do 9,800 divided by 1.22. And don't round here again, 5. And that's going to give you P. And in this case, it gives you $8,000.23. Amount you have at the end should be more than the amount you had at the beginning. So that makes sense. Okay. Jerry invested $4,100 into an annually, so that tells me N equals 1. I'm reading these words. Compounded account with an interest rate of 2.48%. So that tells me R equals 2.48 over 100. Be careful, people do 0.248 all the time. It's 0.0248, as you see here. Now, this asks how long was the term of the investment. If you haven't taken a course where you've done logs and exponentials, this makes no sense. You are not going to be asked to do this. So this is not a question you're going to be asked to do in class. But here's how it's solved. The natural log of the amount you have divided by the principal, then divided by the natural log of what's in here. Natural log is a button on your calculator, but it's log base E of an amount. If you need to ever solve for something that's in the exponent of a formula, you need to use logs. If you haven't seen logs, don't worry, we're not going to have them in this class. This slide was in here. I would just show that you can use this formula for many things. So somebody who's doing financial planning, they'd probably have a built-in calculator to do this stuff. How long do I have to invest this to get this much money? They would be able to solve that this way. All right, so this savings are continually reinvested, periodically compounded interest. We talked about annually. Annual means N equals 1. This tells you what to use for N in the formula. Monthly, N equals 12. Quarterly, N equals 4. That's 4 times year, and daily would be 365. Nominal is used in compounding in terms other than once a year. The effective interest rate ends up being greater than the nominal rate, because if you compound 12 times a year, at the end of 1 year, you will have more than if you had compounded once a year. That's all that's talking about. The effective rate would be what the simple interest rate would have been that got you the same amount of money. So this is a chart that basically summarizes the power of compound interest. Here's our formula. You need to have that available to use. So if I invest $1,000 at 10% for 1 year, and I compound it annually, it's just basically simple interest. I get $1,100. But if I compound, so this would be N equals 2 for semi-annually. Sorry, 2. Get a little more. You notice that N equals 4 here. As N goes up, the amount of money I have goes up. So daily being the most. And it's a $5.16 difference, but nonetheless, it's more. So if we invest $3,000 in an account paying 3%, compounded quarterly, how much will it be worth in 10 years? So I've got to sort out what I have. I have P is 3,000. R is 0.03. That will be 3 divided by 100. 10 year compounded quarterly. That's not a number. I don't see a number when I read this, but I have to translate this into a number that I use, which is N equals 4. So the words are important. Some of you have more trouble in this course reading than you are with numbers. So how much will be worth in 10 years? That's T equals 10. So they do that here. They show you all that. And then when you finish that, you plug those numbers in, and you get $4,045.05 in 10 years. Now, an account is opened with $2,500, gets 2.8%. How much is it worth after 30 years? Compound. Notice I skipped compounded semi-annually. You can't skip that. N equals 2 is what that tells us. When you see this word compounded, you look for the word after it. So there's my N equals 2. There's my T equals 30. There's my interest rate. Now notice the N goes in 2 places. Students often forget that too. So this is just a calculation in your calculator. All right, Scott's saving for a down payment to buy a house. He has a 7.7% interest-bearing account, and he wants to have $10,000 in 5 years. So they're asking what the principal is. So they gave you this amount here. A is $10,000. This is what they want you to find. You plug in everything else. It's semi-annually, so that's N equals 2. The 2 goes here and here. Do not forget that. Sometimes students pick a favorite number and make that under the R all the time. Like it's always 12 or it's always 6. No, it's whatever goes up in this exponent goes here. And then you find what this number is. That multiplies P, so you divide both sides by that, and you can see If you invest $6,853.86, he'll have $10,000 in 5 years. We don't do anything with continuous compounding here, but this is a formula it's a little bit different. This part here comes from this part of the formula when n goes to infinity. Like you compound the money as soon as it gets in. E is a base E exponential. We don't assume you have good knowledge of that in this level course, so we're not going to do continuously compounding, but that is, again, a button on your calculator. That E is a base exponential on your calculator, and you would have the same issue with the exponent. You want to know the exponent. You don't want to do e to the r times t, because that's what it will do. It won't do e to the rt. But we're not going to work with continuous compounding. So this is the big idea. You need to know how to use this formula. And they give us one more where they want to find A, 18 years, new grandchild, and they want to know how much is in if you compound quarterly or monthly. Maybe you're choosing between two certificates of deposit. Total of $10,000 was invested. So that's the P. That was invested. They want to know how much you have at the end. There's just two more examples to go through. So you get different amounts there. And I did part. Here's another one. $1,500 is invested in savings account, 2.5% interest. Notice they compounded quarterly. N is 4. Make sure you put it in both places. Get that. And if you compound monthly, you'll see you get a little more. Actually, it was significantly more here because it was for 5 years. So here the exponent is going to be a 20, although this number in here is slightly larger than it would be when you divide by 12. But here this exponent is actually a 60, 12 times 5. And whenever an exponent grows fast, then this should also be a 12. That is a mistake there. That one should be a 12. So I'm not sure that answer is correct now either. So let me check that. 1,500, 1 plus 0.025 divided by 12, parenthesis, exponent, parenthesis. I could just write 60 or 12 times 5. Actually, that should be 1699.50. Sorry, I believed what the textbook author had for me. I thought that was an awful lot more. It is a little bit more than when you compound quarterly, like 44 cents more. So does it really matter? I don't know. You know, if the first one were in a bank that I always did business with, I'd probably go with that one. If the second one was some new bank, I'd probably not for $4 and or whatever the small amount it was. But it does make a difference. Okay. This one, student loan, company compounds interest every month. This would only be for private loans, by the way. The federal loans are simple interest. I did determine that in my research last semester. So this would be how you'd calculate how much you owed after 2 years. All right. Thank you for joining me for this lesson in quantitative reasoning, and I will see you in class.